100 milliwatts from a basic PZT shoe setup, charging a depleted phone would require 185 hours of walking. That sounds impractical until you realize that most people do not fully deplete their phones. Maintaining the last 20% of battery life through continuous trickle charging during daily activities is entirely feasible with existing piezoelectric technology. Your shoes keep your phone alive at the critical moments when you need it most. What are your feet doing right now? Tell me in the comments. End of section. Next section begins now. Every door in your house squeaks. Every drawer sticks. Every hinge groans. Every sliding mechanism in your home has slowly deteriorated from the day it was installed. And when you hear that squeak, when you feel that resistance, you reach for the same blue and red can that has been lying to you since 1953. WD-40 is not a lubricant. It is a water displacement formula. That is literally what the name stands for. Water displacement. Formula number 40. It was the 40th attempt by a chemist named Norm Larsen at the Rocket Chemical Company to create a formula that would displace water from missile casings to prevent corrosion. It was designed for Atlas missiles during the space race, not for your squeaky door. When you spray WD-40 on a hinge, here is exactly what happens at the molecular level. The solvent carrier, which makes up about 50% of the formula and consists of volatile petroleum distillates similar to lighter fluid, dissolves the existing grime, old lubricant residue, and light corrosion on the metal surfaces. This briefly eliminates friction by creating a clean metal-on-metal interface with a thin film of petroleum distillate between the surfaces. The squeak stops for about 48 hours. Then the volatile solvent evaporates. That is what volatile means. It transitions from liquid to gas at room temperature. The thin film disappears. The metal surfaces are now clean, but completely unprotected. Bare metal on bare metal. The squeak returns, usually louder than before, because WD-40 also stripped away whatever residual lubricant was still partially working. You spray again. The cycle repeats, and the WD-40 company sells another 300 million cans per year. The WD-40 company, headquartered in San Diego, reported $537 million in annual revenue in their most recent fiscal year. Their single product, essentially unchanged since 1953, generates over $500 million annually. That revenue depends entirely on one thing: you buying another can. A permanent fix would destroy their business model. The fix that actually works costs $2 and lasts essentially forever. It is paraffin wax. Paraffin wax is a saturated hydrocarbon derived from petroleum refining, the same family of molecules as motor oil and Vaseline, but in solid form at room temperature. It is the same material used in candles, cheese coatings, crayons, and waterproofing. A block of refined paraffin wax costs $2 at any craft store, grocery store, or online retailer. A single block contains enough material to treat every moving surface in your entire home for the next decade. Here is the detailed physics of why paraffin wax works as a superior lubricant. Wax is a long-chain hydrocarbon, typically containing 20 to 40 carbon atoms per molecule. These long molecules naturally align parallel to surfaces, creating layers that slide easily over each other, similar to a deck of cards. The intermolecular forces between the wax layers, called van der Waals forces, are extremely weak. This weakness is exactly what makes wax slippery. The layers slide past each other with almost zero resistance. When you rub paraffin wax on a metal surface, the wax fills the microscopic scratches, pores, valleys, and imperfections in the metal surface. At the microscopic level, even polished metal looks like a mountain range. Peaks and valleys everywhere. When two metal surfaces slide against each other, these microscopic peaks catch on each other. That catching is friction. That friction is your squeak. Paraffin wax flows into the valleys and covers the peaks, creating a smooth, uniform surface at the microscopic level. The surface passes from a rough metal texture to a smooth wax texture. Wax-on-wax contact has dramatically lower friction than metal-on-metal contact. The coefficient of friction of paraffin wax on steel is 0.04 to 0.10, depending on load, temperature, and surface preparation. For comparison, WD-40 on steel starts at about 0.05 when freshly applied, but rises to 0.20 to 0.30 within days as the solvent evaporates and only a thin residual oil film remains. That residual oil film then collects dust, hair, and airborne particulates, forming a gummy abrasive paste that actually accelerates wear. Paraffin wax does not evaporate at room temperature. Its melting point is 46 to 68 degrees Celsius, well above any temperature your hinge will experience. It does not collect dust because it is a solid, not a sticky liquid. It does not run or drip or migrate away from the contact surfaces. It stays exactly where you put it. The application process exploits a clever physical principle: friction-generated heat. When you rub wax on a hinge pin and then open and close the door repeatedly, the friction between the wax and the metal generates enough localized heat to slightly melt the wax at the contact interface. This micromelting causes the wax to flow into the microscopic surface imperfections and then re-solidify when the motion stops. The result is a precisely fitted wax layer that conforms exactly to the geometry of the specific joint. No machining required. The wax self-machines through the contact process. Let me walk you through every application in your home. Door hinges. Remove the hinge pin by tapping it out from the bottom with a nail and hammer. Rub the wax directly on the pin surface, coating it completely. Reinsert the pin and open and close the door 10 to 15 times. The door will be silent for years. Drawer slides. Pull the drawer completely out. Rub wax on both the wooden or metal rails that the drawer rides on and on the corresponding surfaces inside the drawer opening. Push the drawer in and out 10 times. The drawer will glide like it was mounted on ball bearings. Window tracks. Open the window. Rub wax on the aluminum or vinyl side channels that the window sash rides in. Work the window up and down several times. The window mechanism will operate smoothly regardless of weather, humidity, or temperature changes. Zippers. Rub wax on both sides of the zipper teeth while the zipper is open. Close and open the zipper several times to distribute the wax. The zipper will remain smooth through thousands of cycles. This is particularly valuable for outdoor gear, where zipper failure can be a genuine safety issue. Garage door tracks. Rub wax on the inside of the vertical tracks. The rollers will glide without the groaning and binding that characterizes most garage doors. Unlike spray lubricants, the wax will not attract the dust and debris that constantly accumulates in garages. Table saw fences and router table surfaces. Furniture makers and woodworkers have known about paraffin wax for centuries. Rub wax on the cast iron top of a table saw and wood slides across the surface with almost zero resistance. The wax also prevents rust on the cast iron surface by creating a moisture barrier. Screws and nails. Rub wax on wood screws before driving them. The wax lubricates the threads, reducing the force required to drive the screw by 40 to 60%. The screw is also easier to remove later, because the wax prevents corrosion bonding between the screw and the wood. Curtain rods. Rub wax on the rod. Curtain rings slide freely. This eliminates the jerky, noisy motion that drives people to buy expensive curtain track systems. Snow shovels. Coat the blade of a snow shovel with paraffin wax. Snow and ice slide off the blade instead of sticking. This dramatically reduces the effort required to shovel and prevents the progressive snow buildup on the blade that makes shoveling increasingly difficult. Saw blades. Rub wax on a hand saw blade. The blade cuts through wood with significantly less effort, because the wax reduces friction between the blade sides and the kerf walls. The list continues. Folding table legs, folding chair mechanisms, bicycle chains for dry conditions, sewing machine guides, lock mechanisms, toilet seat hinges, medicine cabinet doors, refrigerator drawers, freezer handles, ladder locks, toolbox drawers, fishing reel mechanisms, musical instrument tuning pegs. Nearly every mechanical joint in your household can benefit from paraffin wax. Now let me address the specific ways that WD-40 causes damage when used as a lubricant. WD-40's primary solvent is a petroleum distillate, similar to Stoddard solvent. This solvent strips protective coatings, dissolves certain plastics and rubbers, and removes natural patinas from metal surfaces. On brass hardware, WD-40 strips the protective lacquer coating that manufacturers apply to prevent tarnishing. The brass then tarnishes rapidly and requires continuous polishing. On rubber gaskets and O-rings, the petroleum distillate swells and softens the rubber, causing it to lose its sealing properties. If you spray WD-40 near plumbing fixtures, the rubber washers in the faucet can swell and cause leaks. On painted surfaces, WD-40 can dissolve or soften certain paint formulations, particularly latex-based paints. Overspray near painted surfaces can leave permanent marks. On wood surfaces, WD-40 penetrates into the wood grain and creates dark stains that are extremely difficult or impossible to remove. If you spray WD-40 on a squeaky wooden floor joint, the surrounding wood may be permanently discolored. On gun mechanisms, WD-40 is the single most common cause of firearm malfunction that gunsmiths encounter. The volatile solvent evaporates and leaves a varnish-like residue that gums up firing pins, extractors, and trigger mechanisms. Every firearms manufacturer explicitly warns against using WD-40 on their products. Paraffin does the opposite of all of these. It preserves surfaces. It does not dissolve coatings. It does not damage rubber. It does not stain wood. It does not leave residues. Museum conservators use paraffin wax to protect metal artifacts from corrosion. Antique firearm restorers use paraffin wax to preserve mechanisms. Furniture makers use it to protect wood surfaces. Luthiers use it to protect musical instruments. A single $2 block of paraffin wax, applied once, with no special tools, no skill requirement, and no safety precautions beyond not eating it, solves every squeaking, sticking, and binding problem in your entire house permanently. The WD-40 Company's $537 million annual revenue is built entirely on convincing you that a temporary solvent is a permanent solution. It is not. The physics is unambiguous. Solid lubricants stay where you put them. Liquid lubricants run away. Wax stays. WD-40 leaves. One costs $2 forever. The other costs $5 every few months forever. The chemistry of WD-40's failure as a lubricant goes deeper than simple evaporation. The primary solvent in WD-40's formula is a petroleum distillate legally classified as Stoddard solvent, a mixture of C7 to C12 aliphatic and alicyclic hydrocarbons. This solvent is excellent at dissolving grease, tar, adhesive residues, and other organic contaminants. That is its designed purpose. It is a cleaner and water displacer. When Stoddard solvent evaporates from a treated surface, it leaves behind a thin film of mineral oil, the non-volatile fraction of the WD-40 formula. This mineral oil film has a dynamic viscosity of approximately 15 to 30 centistokes, comparable to very light machine oil. It provides marginal lubrication for hours to a few days. Then several processes degrade it. The mineral oil layer is thin enough that air oxidation attacks it rapidly. Oxygen molecules react with the hydrocarbon chains, creating peroxide radicals that cross-link the oil molecules into a varnish. This varnish is sticky, not slippery. It increases friction rather than reducing it. Simultaneously, the thin oil film acts as a dust magnet. Every surface in a home has airborne particulate matter settling on it continuously. On a dry surface, these particles sit loosely and can be wiped away. On an oily surface, they embed into the oil film and become permanent. Over weeks and months, the oil film accumulates enough particulate contamination to form an abrasive paste. This paste accelerates mechanical wear on the hinge pin, drawer slide, or other moving surface. Paraffin wax avoids all of these failure modes. It is a solid across the entire residential temperature range. Solid materials do not flow, drip, run, or migrate. They do not collect airborne dust because their surfaces are not adhesive. They do not oxidize at room temperature because the reaction kinetics are too slow in crystalline hydrocarbons. They do not evaporate because their vapor pressure at 20 degrees Celsius is essentially zero. The thermal stability of paraffin adds another advantage. In a garage that reaches 120 degrees Fahrenheit in summer, paraffin with a melting point of 135 degrees Fahrenheit remains solid. WD-40's mineral oil residue, already thin, becomes thinner and runs away from the contact surfaces at elevated temperatures. By autumn, the WD-40 treated hinge is dry and squeaking again. The paraffin treated hinge is unchanged. The coefficient of friction data is unambiguous. Published friction testing on ASTM D2714 tribometers shows paraffin wax on steel maintains a kinetic friction coefficient of 0.04 to 0.06 over 10,000 cycles, with essentially zero degradation. No material buildup, no wear debris, no surface modification. The wax simply slides. Beeswax, another natural wax sometimes recommended as a lubricant, has different properties. Its melting point is lower at 62 to 64 degrees Celsius, making it potentially problematic in extremely hot environments. Its friction coefficient is slightly higher at 0.06 to 0.12 due to its more complex composition. But beeswax has the advantage of being self-produced by beekeepers, making it free for those who maintain hives. In lubricant performance, paraffin is superior. In cost and sustainability, beeswax may be preferable for homesteaders. Carnauba wax, harvested from the leaves of the Brazilian Carnauba